Guten Tag. So here is Law of Sines, day 2. So it says, watch out. When finding angles, it's possible to have one solution, two solutions, or no solutions. This is called the ambiguous case. Okay? So the sine function always has a range between -1 and 1. Angles with a positive sine function value can lie in quadrant 1 and 2. Okay, so to find the other possible angle, we're going to subtract 180. The sum of the angle measures in a triangle is always, I hope you said 180. No triangle can have two obtuse angles. All right, so now let's put all this into play. Okay, so remember yesterday you were doing law of sines and you were finding sides. Okay, so this particular ambiguous case applies when you do angles. All right, so we have measure A is 60 degrees, length AB is 30 inches, BC is 27 inches, and we have to find measure C. So the first thing I want to do is draw a non-right triangle. Okay, That's probably a right triangle, but it is what it is. Now we're going to label A, B, and C. And the problem told you that measure A is 60 degrees. It said that AB is 30 inches. Then it said that BC is 27 inches. Okay, but it asks you to find measure C. So measure C would be right here, and I'm going to call this theta. Okay, so now what you want to do, just like we always do, is you want to find some type of pair. So you have, this is a pair, so we could do sine of 60 over 27 equals, and we have to find measure C. And we know its length, so I could do sine of theta, which theta is measure C, over 30. Okay? Now, from yesterday, how would I solve this, right? We're going to cross multiply, and we get sine theta multiplied. Oops, let me rewrite this. Let's do 27 times sine of theta equals 30 times sine of 60. Okay, now we're going to solve for theta. Okay, so we're going to divide by 27. Now in your calculator, you need to do 30 times sine of 60 first, then hit enter, divide by 27. So you get that sine of theta is going to equal 0.9623. Okay, now remember to solve for the theta. I'm going to bring this over here. Sine theta equals 0.9623. To isolate this theta part, you have to undo sine. So how you do that is take the sine inverse of both sides. Okay, so now you have theta equals the sine inverse of 0.9623. Okay, so now in your calculator where you see the sine function, you're going to hit second, the button second, sine, and that gives you the sine inverse. Okay, so when you do that, you get that theta is equal to 74.2 degrees. Okay, but here's the thing. This could either be 74.2 degrees, or it can be, so this is what I like to call case 1. Case 1 is that the angle measure C is 74.2. Case 2, remember if we go back to here, okay, to find the other possible angle, you're going to subtract from 180. So then for case 2, we're going to do 180 minus 74.2. Okay, and when you do that into your calculator, you get 105.2. 0.8 degrees. So your measure of angle C can either be 74.2 degrees or it can be 105.8 degrees. Okay? All right. Next one. We have the measure of angle C is 89 degrees. We have AC is equal to 34 meters. AB is 26 meters. Find measure B. So we're going to draw a triangle. It's always, it's the first thing we do. Draw a little triangle here. And we're going to label A, B, C. Now, the angle of measure C, they gave it to us, is 89 degrees. Okay. AC is 34 meters. AB is 26 meters. And it asks us to find measure B, so I'm going to take that as theta. Now look to see if you have any pairs, and you do. You have the sine of 89 over 26 is equal to sine of theta, which is B, over 34. Okay, now we're going to cross multiply. We have 34 times sine of 89 equals 26 times sine of theta. And now we're going to divide by 26. So in your calculator, do 34 times sine of 89, hit enter, then divide by 26. So you get that sine theta is equal to 1.3075. Okay, so now remember, to get rid of the sine, you're going to multiply by the sine inverse on both sides. So you have that theta equals the sine inverse of 1.3075. But here's the deal. On that first page, it said that the sine function always has a range between -1 and 1. So look at this number here. That is above 1. Okay? So this is going to be no solution. You can also put this into your calculator, and your calculator is going to tell you domain error. So that's what your calculator is going to say. Because this number is above 1, which is out of the range of a sine function. Okay? So now, let's go to this triangle. So we have our little triangle here. Oops. And we have A, B, and C. Now let's label measure C is 102. And then AC is 21. 21. All right, AB is 24. And we're going to find measure B, so that's our theta. Now I want you to pay close attention to this, okay? Because this one's going to be a little bit different. Now we're going to start it the same. We're going to try to find a pair, and we do have a pair. Sine of 102 over 24 equals sine of theta over 21. Okay? So now we're going to cross multiply. You have 24 times sine of theta equals 21 times sine of 102. Now divide by 24 on both sides. You get that sine theta, actually I'm going to write it up here. You get that sine theta is equal to, so do 21 times sine of 102 into your calculator, hit enter, then divide by 24. You get that sine theta is equal to 0.8559. Now to get theta isolated, you're going to need the inverse of both sides. So now you have theta equals sine inverse of 0.8559. And when you put that into your calculator, you get that theta is equal to 58.9 degrees. Now remember, this is case 1. Case 1. Now we have to go find case 2. So case 2 would be 180 minus 58.9, which gives you 121.1 degrees. Okay, but we can't have a triangle with two obtuse angles. Okay, now remember, obtuse means greater than 90 degrees. So we have a 102 already, and we have a 121. That's two obtuse angles. Okay, so therefore this one's going to get ruled out. Now let's say you forgot about that. What you can do is you can check. Okay, your theta now would say, let's say 121.1. Now do 180 minus 121.1 minus 102. This angle would have been negative 43.1. And you can't have that. So, therefore, case 2 is ruled out. So, theta can only equal 58.9 degrees. Because remember, the sum of your triangles have to equal 180 degrees. And you can't have a negative measure. Okay? So, now let's go to number 9. We're going to first draw our triangle. And then we're going to label A, B, C. And now we have measure B is 95 degrees. We have AC is 34 kilometers. BC is 21 kilometers. And we're going to find measure A, so that's going to be our theta. So look for a pair, and you have one. So sine of 95 over 34 equals sine of theta over 21. Now we're going to cross multiply, and you get 21 times sine of 95 equals 34 times sine of theta. Divide by 34 on both sides. So sine theta is equal to 0.6153. So remember, to solve, we're going to take the inverse of both sides, sine inverse. So this cancels out, and you get theta equals sine inverse of 0.6153. So theta is equal to 38. Okay, now you have to, so this is case 1, remember, case 1. Case 2 would be 180 minus 38, which equals 142 degrees. Okay, so we need to look at our different cases here. Let's see. Looks like we're going to have to rule this one out. Why are we going to rule that out? Because you already have an obtuse angle, because that 95 is greater than 90, and you can't have two obtuse angles. So therefore, your answer for measure A can only be 38 degrees. You can only accept case 1. Okay? Next one. All right, so the first thing I'm going to do is draw my triangle. I have A, B, C, and C's measure is 30. AC is 29. AB is 28. And we're going to find B, so that's going to be theta. So, do you have a pair? You do. Sine of 30 over 28 equals sine of theta over 29. Okay, so now we're going to cross multiply. 28 times sine theta equals 29 times sine 30. Now we're going to divide by 28 on both sides. So you have that sine theta equals 0.5179. All right, so then you're going to do the inverse. Oops. Theta equals sine inverse, 0.5179. 0.5179. So then theta is equal to 31.2 degrees, which this is our case 1. So case 2 is going to be 180 minus 31.2, which gives us 148.8 degrees. So that means I only have one obtuse angle, so both of these will qualify as answers. Okay? So now let's go to our last one. Oops, 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 oops. Okay. Draw my little triangle. Then we have A, B, C. B is 125. BC is 24. AC is 21. And we have to find that one. Alrighty. Do we have a pair? Oh, we do. Okay, good. So now we've got sine of 125 over 21, there's our first pair, equals sine theta over well, notice how this one would have this pair right here, and we don't have a value for that. So this is kind of a new problem in that we're actually going to have to solve for this one first so we can find theta. So make sure BC is 24, AC is 21. Yeah. So we're going to call this alpha. So on the side, let's do sine of 125 over 21 equals sine of alpha over 24. Now cross multiply, you have 21 sine alpha equals 24 sine 125. Divide by 21. Sine of alpha equals 362. Inverse both sides. Alpha equals the sine inverse of 0.9362. So alpha equals 69.4. Okay, so now what I want you to do is so we need to solve for theta. So to solve for theta, we're going to do 180 minus 125 minus 69.4. So 180, I'm doing this in my calculator, is 95.6. Just kidding, that's not true. I didn't put in my calculator right. Let me try this again. 180 minus 125 minus 69.40 is negative 14.4. So problem here, you can't have a negative measure for an angle. So because of that, this is not possible. Not possible. Okay? Because when I did 180 minus 125 minus alpha, alpha was 69.4, it gave us a negative measurement for theta. You can't have that. Okay? So we're all done, and that's it. Okay, bye.